Today we are working in chapter 2, lesson 8. We are on page 155 and our lesson today is on solving percent problems. First, we're going to look at a couple of vocabulary words, proportion and percent proportion. A proportion is an equation that shows two ratios are equivalent. And in a percent proportion, one ratio compares the part to the whole. The other ratio is the equivalent percent written as a fraction with a denominator of 100. So how do we compare parts and wholes? Let's take a look at this. And our learning target today that we're working with is using ratio and rate reasoning to solve real world and mathematical problems. And the second learning standard that we're looking at today is to find a percent of a quantity as a rate per 100. Find a percent of a quantity as a rate per 100. All right, so when we're comparing parts and wholes, and we'll look at three different types. We're looking at fractions, ratios, and percents. When we're looking at a fraction, it's always a part to a whole. The part is always going to go in the numerator of the fraction. And the whole is always going to go in the denominator of the fraction. All right. So that's a fraction, part over whole. When we are looking at ratio, so using the information in the first ratio, fill in the others. So our first ratio is 2/5, and we can write, or 2 to 5, we can write this a couple of other ways. We can write it as a fraction, yes, or we can write it as 2 to 5 with the word 2 in between, or we can write it as 2 to 5 with the colon in between, and we pronounce the colon as the word 2, T-O. And then percent. When we want to write a fraction as a percent, we scale it up or down, depending what the fraction was, to 100. And so 2/5 is equivalent to blank over 100. So we can look denominator to denominator and see that to get from the 5 to the 100, we need to have the same relationship to get from the numerator to the, from the 2 to the new numerator. So whatever we do to the denominator, which in this case was times 20, we also need to do to the numerator times 20. 2 times 20 would give us 40. So 2 is to 5 as 40 is to 100, or 2 out of 5 is equivalent to 40 out of 100. So 40 hundredths can be written as 40%. So 40% of 5 is 2. So the 2 out of 5 is the same as 40 out of 100. So that means that 2 is 40% of 5. Let's look at a real world link in the sample problem just below. Kara is on her school basketball team. She has completed 9 out of 12 free throw shots successfully. 9 out of 12, so that's very good. Write the ratio as a percent and as a fraction in simplest form. So 9/12 doesn't really easily go into a percent. Okay, so what I want to do first as an intermediate step or a middle step is I want to simplify my fraction. So I'll actually do this first. I'll write the fraction in simplest form first and then try to scale up to 100 from there, and I think that'll work better. So 9/12, well, the greatest common factor of 9 and 12 is 3. They're both divisible by 3. So I can use that GCF of 3 to simplify my fraction. So 9 divided by 3 is 3. 12 divided by 3 is 4. So I get 3/4. Well, that's my simplified fraction. And it's also going to help me to write it as a percent. So percent means per 100, right? Percent. Remember, 100 cents in a dollar, 100 years in a century, 100 centimeters in a meter. So percent means per 100. So I can easily go from 4 to 100 by multiplying by 25 in my denominator. So I would need to do the same thing in my numerator times 25. 3 times 25 is 75, 75%, or excuse me, 75 hundredths is the same thing as 75%. So we can easily write that as a percent right there, 75%. Let's turn our page. Now we're going to look at two strategies to find, to solve percent problems. The first one is on page 156, using double number lines to find the whole. And that's not my favorite strategy, to be honest, but it's a good one, and it's a very visual one, okay? And the second strategy is using the percent proportion. So we will learn both strategies, and you can choose which one strategy you want to use for any particular problem, or you may bounce back and forth between the two, especially when you're just beginning. Okay, so let's look at double number lines strategy first. If you know the part and the percent, you can find the whole or the total. You have used bar diagrams to solve percent problems. Double number lines are another way to illustrate percents. Number one and two are completely done for us, these examples. So let's take a look at them. 10 is 25% of what number? So you'll see that we have two number lines. The top number line has the percentages. And we see that 25% is in our problem. We see that 25% is in one of the number lines. And where we see this 10 is 25%. Okay, so let's look at the second number line. The bottom number line has the numbers. The top number line has the percentages. The bottom number line has the numbers. And we see that 10 is equivalent to 25%. And when you look at the number lines, you see that they line up together. And I just want to highlight those so that it stands out. 10 is 25%. 10 is 25%. So you can see how those two things line up really nicely. And that's the purpose of the double number lines. So I see the 25%. And so also on the double number lines, I can see in the top, that's what they made our interval. Each interval increases by 25%. In the bottom number line, 10 was equivalent to 25%. So each of these intervals increases by 10. Okay. So when I get to that 100%, that's the whole. So that means that the whole was 40. So 10 is 25% of 40. And we can use the double number line to help us define that. Number two. Country music makes up 75% of Landon's music library. If he has downloaded 90 country music songs, how many songs does Landon have in his music library? So we see that it's 75% of his library is country, and he has 90 country songs. So 90 is 75%. And when I look at my double number lines, I see that those two numbers line up. Okay, so then the rest of it is, and this problem is done for us, but deciding what the intervals need to be. So I see that 75% is 90. I know that 75% is easily divisible by, and 100% are both easily divisible by 25. So we can count by 25% each time. So add 25% each time. All right, so then likewise, I have 1, 2, 3, 4 intervals. So I want to have 4 intervals here. I don't know what they are, but if I look at the 3 before the 90, so that's the 1, 2, 3, the third of 4 intervals. So I would have 3 jumps or 3 intervals to get here. I can count by 30. So 90 divided by 3 would mean each interval would be 30. So in this case, we're adding 30 each time. Okay, so 0, 30, 60, 90, 100. So that means altogether, how many songs does he have altogether? Well, that's the 100% would be 120 songs altogether. So Landon has 120 songs. Okay, so now let's do some double number lines of our own. This time, we're not given the number lines. They're not set up for us. We have to decide how to set those up. So got it, A. And I know that you can do this in your head. 30 is 50% of what number? It is 30%. 30 is 50% of 60. You can all do that number and you can all do that problem in your head. However, I want us to do this problem with a double number line because we already know that the answer is 60. So we want to just prove that with the double number line with a problem that's easy for us to understand so we can see how the double number lines work for solving. So let's do that over on the left-hand side where we have some workspace. 30 is 50% of what number? So let's do that right here. Letter A, 30 is 50% of what number? Okay, so my top number line is going to be my percentages. And I know that 50% is right in the middle, so I'm going to write that there. And then I'll count back 50% to take me to 0%, and I'll count forward 50% to take me to 100%. So the one number line has just percentages, and the other number line is just going to have the numbers. And again, I know from my problem that 30 is 50%. So I want the 50% to line up with the 30. So I'm going to go ahead and do that first. 30. And then I know that was halfway. So if I double it, this takes me to 60 because that's my interval of plus 30. And then if I work this way, to be 0, the plus 30. So counting by 30, 0 to 30 is 30, 30 to 60 is another 30. So 30 is 6% of what number? What was the whole? The whole was 60. So for letter A, our answer is 60. Okay, letter B has this question. Letter B asks us this. 60 is 20% of what number? Okay, so we'll start with our double, and then we recognize that the 60 is 20%. Okay, so those are the two things that need to line up on our number lines. Our top number line is going to be our percentages. So 20%, that's what we're interested in starting off with. So I'll have 0%, then 20%. 40%, 60%, 80%. I'm just going to make my number line a little bit longer. 100%. Okay. And then the next number line is going to be my numbers. And the 60, the number 60 needs to line up with the 20%. So this number line, okay, the 20% is going to line up with 60. The 0% will line up with the number 0. So what are my intervals going to be here? My intervals are going to be 60. So I'm counting by 60 each time. And I want to make sure when I make my double number lines that my intervals line up exactly. Need to have the same number of intervals, and the intervals need to be equally spaced. Okay. So this is 0%, 20%, 40%, 60%, 80%, 100%. We know that 60 is 20%. So I check my double number lines and I make sure that my 20% on my percentage number line lines up with the number 60 on my number line, and they do. So then I know by looking at that the intervals in my number line, the intervals are 60. So 0 plus 60 is 60, plus 60 is 120, plus 60 is 180, plus 60 is 240, plus 60 is 300. So 60 is 20% of the total 300. So 300 is the answer for B. Okay. Letter C. Peyton spends 60% of her money to buy a new television. If the television costs $300, how much money did she have? So this is 60% of her money is what she spent, and that was $300. So those are the two numbers that need to line up on the two number lines. So let's go ahead and make those. And this one may have to do a little bit of thinking to get our correct intervals. So our top number line, we'll make our percentage. We had 60%. So as I'm thinking about this, I could count by 10%, but it's going to give me more intervals than I really need to have. So I'm looking at 60%, and I know I need to also have 100% because I need to know the total. So the greatest common factor of 60 and 100 is 20. So I'm going to count by 20% on my top number line. Okay, I'm going to say that thinking process again. I could count by 10% if I needed to, but I don't want to have that many intervals. So I want to look at 60% and 100% because that's the number I'm given, 60%. And the number I want to find, how much money does she have altogether, the 100%. The greatest common factor of 60 and 100 is 20. That's the biggest factor that goes into both of those numbers evenly. Okay, so I'm going to count by 20% on my percentage line. Okay, so I'll do that one first. Okay, and then I'll make my number line to match, and we'll fill in those numbers in just a moment. So I make another identical number line below it, match up the hash marks. These are also called tick marks down south. They call them tick marks. So tick marks, hash marks, whatever you want, intervals. Okay. And so 0% will line up with the number 0. And in this case, the number that we knew was 60%. We know that 60% is $300. So those are the two that we need to match up on our number line, on our double number line. 60% is $300. Okay, and so now I look at this from 0 to 300, that's 1, 2, 3 intervals. So if I'm counting up to 300 and I'm starting at 0, that means that each of those intervals is 100. So I'm adding 100 each time. So I'm counting by 100. So 100, 200, we already knew the 300, then 400, then 500. So that means that Peyton altogether had $500. So she had $500. Okay, so those problems are solved with the double number line strategy. It's a great visual strategy, helps you find the greatest common factor. It lets you visually compare them. So let's turn the page and look at page 157, and let's use the percent proportion. So this is just a little bit more just straightforward math and logic and comparison. Okay, so this is just an example to show you part to whole and the in proportions. So the diagram uses a percent proportion to show that 75% of 32 is 24. So we can see that 24 is out of 32. This can be simplified. These are both divisible by 8. 24 divided by 8 would give us 3. 32 divided by 8 would give us 4. So that would simplify to 3/4. If we wanted to write that as a percent, 3/4 as a percent is the same as 24/32 as a percent. This would be 75 hundredths. So it would be written as 75%. So this is just a comparison of different ways that we can work with percents and proportions. Example 3 is all worked out for us. I can get that all on the screen at the same time. There we are. Zoom out a little more. Yeah, that's good. So number 3, 15 is 30% of what number? So this one is a little different. We're solving this with percent proportion. So as soon as we see that 30%, we want to write that as 30 over 100. And we still see in our word problem that the 15 is 30%, and we see these lining up in the proportion instead of lining up on the number line, like in the previous strategy. But both of these work, and we want to make sure that we have the parts matching. So part over whole, part over whole, part over whole. And so then we want to find out, well, what would that be? So 30% of 15 is 30% of what number? So we have part whole, part whole. So now we just need to work backwards to find the missing piece. So if I look from here to here, 15 to, or from 30 to 15, I can see that relationship of dividing by 2. So to get from 100 to my answer, I need to do that same thing. Whatever I did in my numerator, I need to do in my denominator. Divide by 2, that's going to give me 50. Okay, so 15 is 30% of 50. Okay, moving on to number 4. $225 is 75% of what number? So as soon as I see that 75%, I want to write 75 over 100. And I see that the 225 is the portion. 225 is 75%. It's not the whole, it's the part. So as soon as I see that 225 is 75%, I know that those two things need to line up, okay? So the 225 needs to be in my numerator. Okay, and this is a little trickier to see because the numbers are bigger. But if you count by 75, 75 will go into 225 3 times. So you can just kind of look for that relationship. It might be helpful to scale this down to 3/4 and then scale back up. Okay, but whatever I did in my numerator to get from here to here, I need to also do to my denominator, get from there to there. So that's going to be times 3. So it's 300. So 225 is 75% of 300. All right, and let's do a few more examples. Letter D, and we'll work over on the right-hand side of the page because there's a little bit more workspace here. So letter D asks 75 is 15% of what number? So let's work over here. $75 is 15% of what number? I'm just going to abbreviate that number with the number sign. So, and then another strategy we'll talk about is over of, but I'm going to talk about that at the very end. So some of your parents, if you're working on your math practice at home with your parents, they might teach you the is over of strategy, and that is a great strategy as well. Okay. So I'm just going to teach you proportional reasoning here. So as soon as I see the 15%, I'm just going to write that as 1500. Okay. And then when I see that the 75 is 15%, I know that the 75 is the part. It's not the 100%. It doesn't go in the denominator, right? The whole, the 100% would go in the denominator. So when I see that the 75 is 15%, I know that the 75 is a portion, not the whole thing. So the part goes in that, remember, it's part over whole. Okay, so the 75 goes in the numerator because it's not the whole thing. It's only 15%. It's only a part. Okay, so then I'm asking, how do I get from here to here, from 100 to my answer? Well, I want to analyze what happened from here to here and do the same thing in the denominator. So if I count by 15 to see how many times that goes into 75, 15, 30, 45, 60, 75. That goes in 5 times. So times 5. And then here, 100 times 5 is 500. So 75 is 15% of 500. Letter E. So 9 is 36% of what number? Okay, so as soon as I see that 36%, I want to go ahead and write that as 36. As soon as I see that 36%, I want to write that as 36 over 100. And I know that 9 is not the whole because it tells me 9 is 36%. So I know that the 9 is the part, not the whole. So it goes in the numerator, not the denominator. The 9 is the 36%. So then my question is, I want to know, how do I get from here to here? And the answer in the denominator, and the answer is in the numerator. So I ask myself, how would I get from 36 to 9? And that answer is divide by 4. So how would I get from 100 to my answer? I would also divide by 4, and 100 divided by 4 is 25. So 9 is 36% of 25. Letter F, 7. And this one you may be able to do in your head, but we're still going to solve it with the proportion. 7 is 70% of what number? All right. So you can probably do that in your head and know that it's 10, but we're going to prove that with the percent proportion. So 70%, as soon as I see that 70%, I'm going to write that as 70 over 100. And I see that the 7 is the part, not the whole, because it tells me 7 is 70%. So I know that the part goes in the numerator. So 7. And then I want to get to this answer, okay, here. So I look in my numerator to see what happened here. To get from 70 to 7, I divided by 10. So to get from 100 to my answer, I need to divide by 10. And that is going to give me the number 10. So 7 is 70% of 10. Letter G. 7 is 35% of what number? All right. So when I see that 35%, I'm going to write 35 over 100. 7 is the part, so 7 goes in the numerator. And again, I want to go from 100 to my new denominator. So I look in my numerator to see what the pattern is. To get from 35 to 7, I needed to divide by 5. So to get from 100 to my answer, I need to divide by 5. And 100 divided by 5 is 20. So 7 is 35% of 20. And then we have a word problem, real world problem on the next page, 158. And we're looking at the composition of pennies. Before 1982, pennies were 95% zinc and 5% copper. If 100 pennies minted in 1980 have an approximate mass of 15 grams of copper, what is the total mass of 100 pennies? So we see that the 15%, or excuse me, that the 5% is written for us 5 over 100. So we want to find out, excuse me, I lost my spot there. 15 grams of copper were included in that, or in the mass of those 100 pennies. So that's the 5%. So we set up the part that's copper, 15 grams. with the percentage that's copper, 5%. And then we want to look for what the total weight of those 100 pennies were. So to get from 5 to 15, we need to multiply by 3. So to get from 100 to our answer, we need to multiply by 3. So this is 300. So this means that the total mass of the pennies were 300 grams. And out of those 300 grams, 15 grams were copper. That was chapter 2, lesson 8, solving percent problems.